Welcome back to another episode of Integration by Parts, of Learning Integration. I'll be focusing on integration by parts with using the functions e to the power of x, and we're going to be using Leibniz's notation. Okay, so this is how Leibniz would do it. Well, he would use dv over dx, but I'm just using the dashes because this is what would come up in your textbook most of the time, so I'm just trying to make it as easy for you guys. And here is the rules we would use. So we have a function, and it equals e to the x. And when we integrate it, or find the antiderivative, we get e to the x plus c. Now, if we have a function, it equals e to the kx, k being a number, we find the integral or antiderivative, we get e to the kx over k plus c. That's just what happens. Okay, so that is the formula. Those are the rules. Let's do an example. Example 1. I'll show you a technique in example 2 because it's a bit of it doesn't come up much, but it's still a technique that does help. But this example is just getting you into it first. So we have our function, and it's x e to the x. Now we need to find the integral of both sides. The integral of the derivative is the original function, and the integral of this side is integrand x e to the x dx. Okay, so we got to, back here we have u multiplied by v dash. These two, in order to answer this question using this, we need to assume that this is that. So we need to assume that one of these functions is u and one of these functions is v dash. How do we select u? U will be the one that, if derived, will simplify better than the other one. So let's think about that. Is that one, when you derive that, you get 1. When you derive that, you get e to the x. Which one's simplified, or more simplified than my other, is x. So, in that case, we pick x to be u, and we pick ex to be v dash. Okay? Let's write that down. We have u dash, v, and v dash. We've said u is x, and we've said v dash is e to the x. When you derive x, you get 1. When e to the x is, when you find the integral, it's e to the x plus c. The only reason I'm not putting plus c here is because I don't like doing it in this stage. I like doing it in the next stage. You can wait till the very end to put your plus c, but I do it in the question as I'm doing it, but I just don't do it in this stage. Okay? So that means if we know what we need to find, then we can now sub them in to the formula. So we have our integral of x e to the power of x dx, and that equals u, which we've said is x, v, which we said is e to the x, subtract the integral of u dash, which is 1, v is e to the x. 1 multiplied by e to the x is e to the x dx. Okay, and we have our variables and we have our equation. We can answer the question. Let's say these stay the same. We don't need to change that yet. We need to focus on this part. Subtract. What's the integral of e to the x? E to the x plus c. We said it at the very beginning. Now don't just write e to the x plus c. We have to multiply this negative onto both of these. Okay. So we have x e to the x. Negative multiplied by e to the x is negative e to the x. Negative multiplied by positive c is negative c. Okay, so I'm going to say h is equal to negative c. Therefore, I can write positive h instead of negative c. I'm also going to factor out e to the x, and factoring out e to the x will look like something like this. And then the plus h. Okay? This is our simplified version of this. This is the exact same as this. Okay? And that means that is your answer. Okay, so for our second example, here's where I'm going to use the technique. So we have dy dx is equal to e to the power of x sine x. Okay. When we find the integral of both sides, we get y equals the integrand e to the power of x sine x dx. Okay, now, which one simplifies when it's... If we had to pick one that would simplify it when it's derived, which one would we pick? To me, when we derive either one, they don't really simplify. That one would just change. It wouldn't simplify, it would just change to cos. And this one would just stay e to the x. I only picked this one because it just stays e to the x. It doesn't change. So, if we write that, u, because we're putting this one as u, and this one as v dash. So u is e to the x. That means u dash would be e to the x, because the derivative of e to the x is e to the x. Okay? V and v dash. We know that v dash is sine x, and v, what's the integral of sine x? Negative cos x plus c. So I'm going to write the negative cos, but like I said before, I don't like putting the plus c at this stage. I'm going to put it in later, because the less I have to deal with now, the better. But I do like adding it in later for accuracy. Okay? So, we have what we need to solve this. Okay? We know the equation is somewhere here. Okay. So what do we start with? We started with the integral of e to the x multiplied by sine x dx. Okay, so we're assuming this is this. Now we can answer this. U, e to the x, v, negative cos x. Subtract integral u dash, e to the x, v, negative cos x. And it fit in a dx down there. Okay? So now we have our equation. Now let's solve it. Okay? E to the x multiplied by negative cos x is negative ex cos x. Subtract the integral of e to the x multiplied by negative cos x. Well, if we multiplied that together, we'd get negative e to the x cos x, just like here. But because essentially we have to get rid of that negative there, because that negative, that would be the same as negative 1 multiplied by cos x, because negative 1 multiplied by cos x is negative cos x. So essentially there's an invisible 1 there. So we're going to factor that out, because that's multiplication by a constant. So we're going to multiply that out, and we're going to get a positive, because a negative multiplied by a negative is a positive. Now, all we have to find the integral of is e to the x cos x. No more negative, because we multiplied it out. Now this is the problem, because we still have two functions left. Okay, what does that mean? Second integration by parts. So, okay, so this is going to be the second int by parts. Okie dokie. We're looking for the integral of e to the x cos x dx. Well, now we're back to the beginning. We need to find, we have to choose one of these to be a u and one of these to be a v dash. Okay, so I'm going to pick the ex again to be the u, and I'm going to pick the cos x to be the v dash. So u equal to ex, the u dash will be equal to ex, the v and the v dash. Now the v dash is cos x, and v, what's the integral of cos x? Sin x plus c. But I'm not going to put the plus c in here, because I don't like to do it in this step. Okay? So, we are just like, if I can find the piece of paper, we have to use this, the formula. Okay? So, derivative, the integral of e to the x cos x dx equals u is e to the x, v is sin x. Okay, minus the integral u dash is e to the x, v is sin x. Now, you may be thinking, well, we're kind of stuck in a loop. Every time we derive this, we just keep, these will just cycle through, causes and sines, and this will just cycle on ex. So we'll always be having two functions. So how do we deal with that? Well, before you have a panic attack, let's focus on inputting this, because this is the same as that, and that is the same as that. We're going to input this in that, and just see what it looks like. So we have negative e to the x cos x plus e to the x sin x minus the integral of e to the x sin x dx. Now I'm going to fit the dx down here in the bottom, but that's multiplied on. I'm just running out of room. Okay, now you may see something that looks similar, and I'm hoping you do, because if we rewrite what we're trying to find, e to the x sin x dx, you can see that this is the exact same as that. And that's why I did this, to show you that this sometimes comes up. You get this, and it's equal to that. That's good. That means we don't have to worry about it, finding the integral of this. This is subtracted. That is positive, and this is a negative. If we were to add this on both sides, we would get 2 multiplied by this, because there'd be 2 of them. And if we had this, and we added another one of this on, we would be negating it, because it would be a subtraction. Or you could think of it as adding this, taking this, and bringing it on the other side, which would make it a positive. Okay? Let's do that. So e to the x sin x dx plus the integral of e to the x sin x dx equals negative e to the x cos x plus e to the x sin x. Okay, I hope I didn't confuse you, but what I did was I just added that onto the other side. See? That means that we have 2 of them. So we could say 2 times one of that would be the same as having 2 of them. So 2 multiplied by the integral of e to the x sine x dx is the exact same as saying that. So that's what we're going to write. Equals negative e to the x cos x plus e to the x sine x. Okay, so we don't need to find the integral of this up here because we've just managed to rearrange the whole equation a bit and turn it to this. We have a 2 over here. We want to find the integral of that. We don't want to find the integral of 2 times of that. So how do we do that? We bring the 2 and we divide it on this side. We divide a 2 from either side, which will cancel out this, and have a divide 2 on this side. Essentially, we're bringing the 2 over the other side, and the only way you can do that is by dividing it. So, and I'm also going to rearrange this because that's a positive e to the power of x multiplied by sine x, and this is a negative e to the power of x cos x. I'm going to rearrange it, and that will make it so the negative is on the end. All over 2. Okay, and that isn't quite the answer because the answer would have a plus c on the end. And I didn't, because we're chopping and changing so much, I didn't want to have to deal with plus c's all through it. So I'm just going to stick a plus c on the end. That is technically correct. I know in other questions I have like negative c's and negative 2c's or plus 2c's and whatnot. But for this question, I didn't want to add the c's because I didn't want to confuse anyone. But that's the answer there. If you wanted to, you could go a step further and factor out the e to the x. So you'd be left with this. And that would be the same. But this is fine. That there is the answer to the question. I hope you learnt something, and I hope that helped. Have a good day. Thanks for watching.